In today's video, we look at the product and quotient rules. Let's begin by examining the function k of x equals f of x times g of x for fg differentiable functions. That is, look at the product of differentiable functions. As we've been doing, we're going to plug it in to the limit definition of the derivative. Using the definition of a product of functions from pre-calculus, this is f of x plus h times g of x plus h minus f of x times g of x. Now, right now we've run into a bit of a problem. There's nothing we can do with this right now. We need to try and manipulate this. So, to manipulate this, let's go ahead and take a look at a rectangular area. Now, within this rectangular area, let's draw two more rectangles. So we'll have that there, and we're going to have, let's say, this here. We're going to say this distance so it should go all the way out there. That is f of x. Let's draw arrows instead. Trying to erase. Gosh. Whatever. Just to redraw that there. So this distance here is f of x. We're going to say that this distance is g of x. Then we're going to say that this tiny distance here is h, and so is this tiny distance here. So in other words, what that means is that this is g of x plus h, and then this will be f of x plus h. So this area in here is f of x times g of x. What is this area? Right? We want to find the area of this top rectangle. Well, that would be f of x plus h, the length, times the width. And the width of it would be g of x plus h minus g of x. See that? Now, what about this distance here? Well, that would be g of x plus h times f of x plus h minus f of x. So why don't we now the area of this entire rectangle would be this f of x plus h times g of x plus h. Now, what we see in the numerator of this limit, f of x plus h minus, f of x plus h times g of x plus h minus f of x times g of x. That would be the area of this upper rectangle and this this rectangle to the right. So in other words, the area that we're going to be left with is this area plus this area. This will now allow us to write this limit as the limit h approaches 0 f of x plus h times g of x plus h minus g of x plus g of x plus h times f of x plus h minus f of x. We can now write this as two limits. Each of these limits can be written as a product of limits. Like so. We can now evaluate each of these limits. This first limit would just be f of x. That second limit is g prime of x. That third limit is g of x. And that fourth limit is f prime of x. And so this gives us the product rule. So the product rule says, let f of x and g of x be differentiable functions, then the derivative of f of x times g of x is equal to f of x times g prime of x plus g of x times f prime of x. In other words, if you take the derivative of a product of functions, it is the first function times the derivative of the second function plus the second function times the derivative of the first function. We will now consider the function k of x is equal to f of x over g of x, where obviously g of x cannot be 0, and f and g are differentiable functions. Now, if we write it this way, what we can do is we can say f of x would equal h of x times g of x. Now we can use the product rule to evaluate this. So we're not going to plug this in to the limit definition. F prime of x would equal h of x times g prime of x plus g of x times h prime of x. Our goal here, I'm going to underline it, is we want to solve for h prime of x algebraically. So if we subtract the h of x times g prime of x from both sides, we're left with this. Now we have to divide by that g of x. Now what we have to do is we have to substitute. Oops, I'm sorry, I forgot to write h prime of x equals that. Now what we have to do is we have to replace h of x with this f over g. So this equals f prime of x minus f of x over g of x times g prime. That is all over g. We have to find common denominator, so we have f prime times g minus f times g prime. That'll be over g of x, and then that whole thing is divided by g of x. Now we can simplify this further. All over g of x squared. So this is the quotient rule. It states that f of x and g of x be differentiable functions, then the derivative of f of x over g of x is equal g of x times f prime minus f of x times g prime all over g of x squared. So if you take the derivative of a quotient of functions, the result is denominator times derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. We finish this video with a few examples. First, let's use the product rule to find the derivative of this function. Now what we could do is FOIL this out first and then differentiate it, but we want to practice the product rule. So product rule states it's the first function times the derivative of the second function plus the second function times the derivative of the first function. Now we want to simplify this. FOILing out that first part, distributing through that second part, and now grouping and combining like terms. We get 15x to the fourth plus 3x squared minus 10. Now let's go ahead and differentiate this function. So this is a quotient rule, right, which says we take the denominator multiply it by the derivative of the numerator, subtract out the numerator, times the derivative of the denominator, and put that all over the denominator squared. Now it's just a matter of simplifying this. So expanding out that first term, expanding out that second term, and let's just leave the denominator alone. Now all we have to do is combine like terms, and we should get negative 8x to the fourth minus 44x cubed plus 14x squared minus 2x plus 5 all over x squared minus 7x plus 1 quantity squared. And we have one last example. We want to find the second derivative of this function. Well, first, let's do this. Factor out an x. We'll be left with x plus 1 times x squared minus x plus 1 all over x to the fourth. This x here is going to cancel with one of the x's in the denominator. Now if we look at this is just x cubed plus 1. We can now write this as 1 plus x to the minus 3. So you could do quotient rule here. Or using algebra, you can first simplify it, and now look, it's a simple power rule. We'll be left with negative 3x to the minus 4 for the first derivative, and so the second derivative is 12x to the minus 5, which is 12 over x to the fifth. And if you were to use quotient rule on this, you would also get 12x to the fifth. That concludes this video on the product and quotient rules. In the next video, I believe we will be looking at the chain rule.